Here are the warm-up questions. Well, unfreeze the screen for you. Solve for theta between 0 and 2 pi. I'll put up the answers in a bit. Okay, let's see how you did on the first one. Did you get a reference angle of 0.73? Remember, when doing a reference angle, you have to do the positive part. Then once you have your reference angle, sine is negative in quadrants 3 and quadrants 4. So we get 3.87 and 5.55. Here is our next one. So you get tan by itself to get negative 3/8. Reference angle, 0.359. Then quadrants 2 and quadrants 4, because tan is negative. So these two were 2 review questions with calculator. Next questions are going to be without calculator. Usually if it's non-calculator, either it comes from your unit circle, or there's another way you can do it without your calculator. Now this one, when you get cos theta by itself to be 4, you can do that because it's impossible. Think about cos as adjacent over hypotenuse. The adjacent side would be 4, the hypotenuse 1. You can't draw a right angle triangle where the hypotenuse is less than the adjacent side. So that's why this one is not possible. Now, what chapter 7 does that's different than chapter 6 is this part that I've underlined in green. So now we're going to solve part D. Root 3 tan theta plus 1 equals 0. But instead of solving like normal, like the first ones, you notice how we had 0 to 2 pi? Now, we're going to solve for all the real numbers. And what it's going to do is it's going to actually combine 2 things you learned in chapter 6 together. It's going to combine solving between 0 and 2 pi, which you know how to do, right? You would get tan by itself, negative 1 over root 3. Maybe you recognize that negative 1 over root 3 is the same as negative root 3 over 3. Since this is non-calculator, it should be a hint that it's something on your unit circle. So root 3 over 3 is on our unit circle, and once around your unit circle, it's your pi over 6 family. Tan is negative in quadrants 2 and 4. This is 2 and 4. And so you would get your answers. This would be how you would normally solve this in chapter 6. Now, what chapter 7 does is it says we don't just go once around the circle. We go an infinite amount of times around the circle. That's what theta ER means. Theta can be any number, can be any angle. You could have it up to 2 pi, but you could go up to 4 pi, up to 6 pi, multiple times around. So what we do is we take each of our answers and we say, how do I write every single angle that ends at 5 pi over 6? Do you remember writing all the coterminal angles of something? Where we just said, I'm going to take 5 pi over 6, I'm going to add 2 pi as many times as I want. So I went 2 pi times k, where k was an integer. That was writing all the coterminal angles. So chapter 7 says, we're going to take these 2 answers and add 2 pi times k. And in chapter 7, they like to write the k in between the 2 and the pi. So instead of writing 2, if you write 2 pi k or 2k pi, it's identical. In chapter 6, I like to write it as 2 pi times k because in our mind we were taking 2 pi and multiplying it by as many times as we wanted. So it was easier to visualize it that way. I guess in proper math writing, you write the pi at the end. I guess. So they're identical. And then this is called the general solution because it includes every single possible answer, no matter how many times you go around your unit circle. Your domain could be everything. In chapter 6, we always restricted our domain. In fact, since grade 10, we've been restricting our domain. In grade 10, you just did right-angled triangles. So you really only look for answers between 0 and 90 degrees. In grade 11, you introduced the cast rule, but you only went once around the circle. In chapter 6, sometimes we went backwards, sometimes we went forwards, sometimes we went forwards and backwards, but we usually restricted it from like, oh, now we're going from negative 2 pi to 2 pi. In chapter 7, we introduce, let's just solve it completely, every single possible answer. And so we write our solutions like this. Now, I've got a little visual here of 5 pi over 6 and 11 pi over 6. And if you look at the visual, if you jump from 5 pi over 6 to 11 pi over 6, can you see that that's perfectly halfway around the circle? And then if you jump from 11 pi over 6 back to 5 pi over 6, that's halfway around the circle. And this is something that happens with tan. We're going to, most of the time, find our answers between 0 and 2 pi and add 2k pi just like this. But with tangent, we can even write this more elegantly like this. Does it make sense that if I started at 5 pi over 6 and I jumped pi, I'd get down to here. And if I jumped pi, I'd be back to this one. And pi, and jumping by pi would get me all of those answers over and over and over and over again. So this means the same as this. Sometimes in a multiple choice question, they give the more elegant answers, so you do need to be able to recognize that and understand why they're the same. But in a long answer question, you could write it this way or this way. So, we are going to write out the steps that we just did for this question. These are the steps for the general solution. In a question, you know it's a general solution if they say, find the general solution, or if they list the domain as theta belongs to all real numbers, or technically, if they don't say anything about the domain, you are supposed to assume the domain is everything. So what did we do in that question? Well, step 1, you just solved like normal, like you would in chapter 6, from 0 to 2 pi. Then whatever answers you find, step 2 is you write all the coterminal ones with that one, and to write a coterminal angle, you just add 2k pi, state that k has to be an integer, and this is the general solution. So really, the general solution is a review of 2 things you did in chapter 6. So it's not like we're learning something crazy new in chapter 7. And all of the solving questions will be good practice for you for getting ready for your test. So once you have that written down, if you turn to example 1, you can put an X through example 1. Because we're going to do a couple of different examples instead. Here is our first one. It's like a chapter 6 question that says solve for theta, but this time it says theta is all real numbers. And we're going to solve 7 sine theta plus 1 equals 0. So first of all, you would get sine theta by itself. And then you'd find your reference angle by doing sine inverse of positive 1/7. So instead of example 1, I've got 3 separate examples for you, so wherever you find space, you can write them down. So once you found your reference angle, well, solving between 0 and 2 pi, sine is negative, in quadrants 3 and quadrants 4. So once you found your answers between 0 and 2 pi, then our final answer would just be adding 2k pi to each of them. So again, if we see it's a general solution question, we solve it like normal from 0 to 2 pi. Once we found those answers, we just write all the coterminal ones with each of them by adding 2k pi. And that's the general solution. So the second one here that I'm going to put up, I want you to try on your own. And I'll put the answer up in a second. Are we ready? Everybody on this one? Almost. Okay, so try this one on your own. I just have the answer under there without any work. All right, let's see how you did. Did you get 1.77 and 4.51? And then you'd add 2k pi to each of them. All right, last one. We are going to work on this one together. First of all, I've mentioned it a couple times, but I haven't done it yet. I'm going to hand out your formula sheets. Because we need our quadratic formula on this one. There is our quadratic formula. So recommendation is to use your formula sheet as a bookmark in your textbook. Sometimes students even I had one student one year, cut it out smaller and laminate it so it was like a really nice bookmark. So on your formula sheet, you have the quadratic formula. The quadratic formula is for x squared. We have tan squared, so plugging in everything into our formula would give us tan theta equals that, and simplifying gives us -3 plus or minus the square root of 37 over 2. Obviously, not on our pi plate. Next, and this is going to happen with any solving trig equation, you'll probably start by solving between 0 and 2 pi. So I split this up because we have one answer with the plus sign, one answer with the minus sign. So for both of these, we need to find our reference angle, use our cast rule, and solve for theta. So we'll do the one on the left first. I take this number, I would type it in my calculator just to see what it's equal to. So typing it into my calculator, I got 1.54 when I type that fraction in. That, I can now do tan inverse of that to find my reference angle, which is 0.995. And once we have our reference angle, tan is positive in quadrant 1 and quadrant 3. So we can find our answers using our calculator in quadrant 1 and in quadrant 3. The final exam used to always have all their answers to 3 decimal places. So when it doesn't say what to round it to, suggestion is to round to 3 decimal places. We do the same thing on the other side. We say, okay, first I'm going to type that into my calculator to see what it's equal to. Negative 4.541. Then I'm going to find my reference angle, but I have to find my reference angle of the positive value. So I type that in my calculator, and I find out my reference angle is 1.354. Then on the right-hand side, my cast rule would say, oh, tan is negative. Tan is negative in quadrants 2 and quadrant 4. So we use our reference angle to find the answer in quadrant 2 and quadrant 4, and we get those 2 answers. It is usually at this time in the question that you have forgotten what the original question even said, because you've done so much math. In math, you often have to reread the question. If the question at the beginning said, solve for theta, 0 less than or equal to theta less than or equal to 2 pi, if they gave us that domain, we would be done. So I'm going to scroll back up, I'm going to read the question. What domain did they tell us? They didn't tell us anything. It just said, solve for theta. So the general solution, usually they're kind, and usually I'll be kind on your exam. When they used to have a provincial exam, they would either say, solve for the general solution, or they would write theta ER. I'll do the same thing. But technically, if nothing is listed, it does mean find the general solution. So we've solved for 0 to 2 pi. We now need to write all the coterminal ones for each of these. So I'm going to take all 4 of those answers and list them. I listed them numerically from smallest to biggest. Doesn't matter the order. And then add 2k pi to each of them. And this will be your general solution. Questions there, 5, 6, and 9, you can circle.